Greetings and welcome. So today we're looking at our first example of a hyperbola and how to kind of analyze an equation to graph it and then to find all of the pertinent information regarding it. So we're going to do a couple examples here. And first of all, the first thing you'd want to figure out is what direction is this hyperbola facing? And I just want to point out, actually, I know this is a hyperbola and not an ellipse because there's a minus sign here and not a plus sign. So instantly, this would be a different problem just with that one little line drawn there. So regarding what direction it's facing, ellipse masters might be tempted to say this is vertical because they see a larger denominator under the y. However, they would be wrong because technically this minus sign you could think of as being if I could think of this as plus and then put a negative 9 down there, and now I think you'd agree that negative 9 is smaller than 4. So this is actually not going to be a vertically oriented hyperbola. It's horizontally. And the way I figure that out is whichever fraction is positive. So first of all, I know it's horizontal based off of x frac is positive. All right, and that's my only reason. Okay, and that's going to be sufficient for us. So that means a is going to equal the square root of the positive fractions denominator. Okay, which in this case the square root of 4 is 2, and b is similarly going to be the square root of the negative fractions denominator, so the square root of 9 is 3. And here's a unique situation. Compared to ellipses, hyperbolas can kind of be, I guess, wider than they are long, if you want to think of it that way, where b can be a number larger than a. All right, so that can seem a little unusual. So let's see. So there's a and b, and then to find c, we had this convenient equation, perhaps a familiar one to us. A squared plus b squared equals c squared, and that one should be easy to memorize. So I would have 2 squared is 4, 3 squared is 9, set that equal to c squared, so that's 13 equals c squared, and root both sides. Technically plus or minus, don't forget it, but I'm only going to consider the positive values of c anyway, so c is the square root of 13. Is what we'll consider. So I've got A, B, and C. And let's see, I guess it also would be helpful to know what my center is. Maybe I should have started there. So let's see. H is always going to be the opposite of the number with the x, so that's positive 1. K is always the opposite of the number with the y, which is negative 3. And these numbers are always paired no matter which orientation it is, if it's horizontal or vertical. So let's see. So there's our center, and I guess I could probably find the vertices, but maybe I'll wait until I graph it. Let's see if I can. I think I've got a. Yeah, here we are. Hopefully you guys can see some of these. I think I'll fit it right here. So let's plot some of our information here. So let's see. So I know the center is at over 1 down 3. So here's my center. Maybe I'll choose a darker color. Right? So there's my center. It's horizontally oriented. So to find my vertices, I'm going to go over 2. So 1, 2. Here's one vertex. And backwards 2, so 1, 2, there's another vertex, okay? And then to find the endpoints of my conjugate axis, I will go up and down by b. And in this case, b is bigger than a was. Not always the case. And so currently, the only points that are actually on my hyperbola are these two. None of the others are. So I got to figure out how am I going to graph this. And what you do is you create the box. All right, I think I'll do this box in black. The box which is going to pass through all 4 of those points. So kind of a box that is the transverse axis long and the conjugate axis in width. All right, and what I'm interested in about this box is its diagonals. I'm going to extend those diagonals. They'll also happen to pass through the center, I want to point out. And look something like this. And these diagonals are also not part of the curve or the graph that makes up the hyperbola. It's just going to help me in creating it. And these diagonals are going to be the asymptotes, which is spelled ASYMP T, of my graph. That's a lot of consonants in a row, that feels. So let's now graph the actual curve. So the curve goes from my, from my vertices, so this is horizontally oriented, and I draw kind of 1/4 of it at a time. So one approaches this asymptote, gets infinitely close and never gets there. Here's another, and then here's this vertex, and it approaches that asymptote and never gets there, and that approaches that asymptote and never gets there. So this hyperbola is symmetric kind of at both the transverse and conjugate axes. And then let's actually plot where the foci are as well. Those are valuable to know. So to find the foci, let's see, square root of 13. That's bigger than the square root of 9, smaller than the square root of 16, so it's somewhere between 3 and 4. All right, and it's actually, let's see, 4 units away from 9 and 3 units away. So I'm guessing it's a little bit closer to 4 than 3. So I'm going to move 1, 2, 3, 4, and back up a little bit, somewhere like here. And if I go 1, 2, 3, 4, and somewhere between 3 and 4, those would be my foci. So there would be like F1 and F2 if I wanted to label those. And that would be my hyperbola. So let's actually find out what the coordinates of all these points are. So the vertices, this being horizontally oriented, I would take A and add it and subtract it to the horizontal coordinate, right? So what does that give me? That would have given me 1 plus 2 is 3, and 1 minus 2 is -1. And let's see, does that agree? -1, -3, there's 1, and over 3 down 3, there's the other one. So that seems to agree. Let's see, so endpoints of conjugate axis, I would add and subtract B to my y coordinate, because, right, it's not vertical, right? And let's see, so that gives me 1, 0 when I add it. -3 plus 3 is 0. -3 minus 3 is -6, so there's the other one. And over 1, 0, right? And over 1, down 6. So those are the endpoints of the conjugate axis. And then let's throw the foci in there for good measure. So that's going to be on the same axis as our vertices, so that's 1 plus or minus the square root of 13, comma, -3. And that being a square root that can't be reduced, this is a perfectly fine way to represent that. Although you could find the 2 decimals of 1 plus the square root of 13, 1 minus the square root of 13. They should land somewhere around there and there. All right, so there's our first example where I'm given an equation and I gather all of this information from it. So let's do one more example where this time we will have a couple facts and we'll try to derive the equation from it. Let's see, over here I've got one pre-selected. So let's see. So write the equation in standard form. Alright, and let's see, let me switch. If the foci are 7, 1, so here's my first fact, 7, 1, and -3, 1. So there's the foci. And what if I told you the transverse axis is 8 units in length. Okay, so there's 2 facts that I know, and it doesn't seem like a lot, but it will be. It's actually not a bad idea to start off with a sketch, I suppose, and try to derive some information from there. Although you'll see that we'll actually be able to derive all of it without a sketch anyway. So the type of information I'm looking for the center. All right, I need that for my equation, so I need HK. I'm looking for A, right? I'm looking for B and C. So I think I need 5 things. Technically, C is not needed to get the equation in standard form. In this case, the foci are going to relate to C, so that'll be helpful. But even if they didn't, even if all my objective was to write it in standard form, I would still find C nonetheless because it's valuable information. So let's see. What do I know? I know the transverse axis is 8 units long. And earlier in a previous video introducing hyperbolas, we said that the transverse axis is 2a units. All right. So this 8 is twice the value of a. So 2a is equal to 8. Therefore, a must equal 4. All right. And there's, I think, our first fact. And this fact does not tell me the orientation. I don't know if this is vertical or horizontal. All right, that doesn't help me out. But let's see. Let's look at this other fact, and this one's got quite a few hints in it. Let's see. Oh wow, this is full of gold right here. So the foci, all right, I told you are going to be along the same axis as the transverse axis. All right, they're always on the same points as the vertices, or on the same line as the vertices. And notice this, that the coordinate that's changing, x is the coordinate that changes. Now, unless this was some like weird diagonal or rotated hyperbola, it's only going to open up or down or left to right. Okay, but since x is the coordinate that changes, this is actually telling me that it's got to be horizontal. All right, so this tells me horizontal. Whereas if the y coordinate was the one that was changing, and it was the foci or say the endpoints of the transverse axis, that would then tell me that it must be vertical. All right, so that's kind of one piece of information I can gather there. Another piece of information is the center. So let's actually do some work and figure out what the center is. If I know the 2 foci, the foci are C units away from the center. So these are both the same distance from the center. So one of the things I could do is just do midpoint formula. Actually, I'll write it down in a little fact for us to bring along. So the midpoint formula is the average of the x's, so add them together, divide by 2, and the average of the y's, add them together, divide by 2. So the midpoint formula for that to find the center is going to equal, let's see, 7 plus a negative 3, divide by 2, and 1 plus 1, divide by 2. So this is equal to 7 plus negative 3 is 4, 4 divided by 2 is 2, and 1 plus 1 is 2, divided by 2 is 1. So my center is actually 2, 1. So 2 is h, 1 is k. And that's actually another thing I want to point out, is the numbers that stayed the same will have to, whatever coordinate that is, will have to be the same coordinate for the center. And since these are the foci, it will also be the same y-coordinate for our vertices if I needed that information later on. Let's see, so I haven't yet found, I don't think I can find B yet. I can't do that yet. But the foci are helpful at finding C, right? Earlier I said that these points are going to be C units away from the center. So I guess that's the next thing I'd be interested in is how far, all right, so little c will equal the distance from foci to center, right? And since these are along the same axis, I mean, I could do the proper distance formula, but I'm not even going to bother with that. I'm just going to absolute value the difference between their changing coordinates. So 7 minus 2 is 5, right? And if I subtracted it in the other direction, that's why I wrote the absolute value there. So C is 5. Alright, so I've currently got H and K, I've got A, I've got C. C I technically don't need to write the equation in standard form, but I need it in order to find B, which is needed. So let's see, so the last little fact that's going to help us do that is this formula, A squared plus B squared is equal to C squared. So I'm going to plug in what I know, solve for what I don't, classic algebra situation. 4 plugged in for A, that's 16 plus B squared is equal to 5 plugged in for C is 25. Subtract 16 from both sides. I believe that's 9, and B is going to equal 3. Technically plus or minus 3 here regarding the algebra, but I'm merely interested in the positive since I'm talking about a distance here. So now I believe I've got everything I need to know to write the equation. And what is the standard form for an equation? Well, there's 2 actually we could pick from. Actually, if I scroll over here, I'll even show it to you. There's 2 to pick from. So there's this one or this one. And the way I pick is completely based off of the orientation. So because I happen to know that this is going to be horizontally oriented, I believe is what we decided, was it? Yes. I'm going to pick the first of the 2 equations. So that one's the x minus h squared all over a squared minus y minus k squared all over b squared, and equals 1. So let's plug in what we know. So x minus, let's see, h was 2, wasn't it? A was 4, right? So plug in 4. 4 squared is 16. Minus B, let's see, is 3. Let's see. So B squared is 9. Y minus what squared equals 1. And let's see, what's the value of K? Was 1. So here is the equation in standard form. Based off of those handful of facts, I was able to kind of assemble all of the other information that I needed based off of those 2 pieces of information. Alright, so thank you so much for watching, and I'll talk to you guys soon. Bye.